Hello, everybody. Welcome back. All right, so today we're going to be talking about function combinations. So my plan is to go over some examples and just kind of review what the different ways you can combine functions are. And then I'm going to give you a chance to do some practice problems where the answers are going to pop up so that you can kind of check your understanding before moving on to even more practice in class. All right, so first off, what does it mean to combine? Okay, right? Why are these called function combinations? What do we already know or use in algebra to combine or simplify? Well, sorry, we use addition and subtraction. Think about what some other main operations are. I'm giving you a second to think about that, but hopefully you came up with multiplying and dividing, okay? So those are operations you've used before, all right? You use them to add like numbers and stuff together, okay? But now we're going to kick that up a level and we are going to use those four operations to combine full-on functions and sets of terms, okay? Because if we can combine individual values or constants, then we can do that to functions. Absolutely. Of course, we can totally do that. So what I'm going to go through right now is the notation and help you see what that's going to mean in terms of the actual math you have to do, okay? So just a heads up, for all of these problems that we're going to be doing right now, we are going to use these functions at the top as our just example functions, okay? So first operation that we're going to talk about is addition, okay? So addition symbol. If you see an addition symbol in between the two function names, or if you see it in between two sets of function notation, that means you're going to add some functions together. Now I used F and G generically here, but you can do this with anything. Okay, so if you look at letter A, for example, it says f plus n. What that really means is take whatever function is f of x and add it to whatever function is named n of x. And so if you look above, the function named f of x is really, so this function is really 5x squared plus 15x minus 30. So I've substituted this entire algebraic expression in for the name f of x. And then n of x is really 2x squared minus 1. So I'm going to add 2x squared minus 1. All right? And then I'm going to combine any terms that are the same. And so in this case, the terms that are the same are 5x squared and 2x squared. So it's going to be 7x squared. There isn't anything that's in common with 15x, but I can subtract 1 from negative 30 and get negative 31. Okay, so what we have here is a new function. This function is the combination of adding f and n together. Now, if you wanted to try B, you can. There's going to be a full copy of all the answers and example problems on Schoology for you. Okay, so I'm going to move on to our next operation, which is subtraction. Okay, now a little heads up. Above us, to just make things a little bit easier, I didn't include parentheses, but technically every time you substitute, you should put whatever you're substituting in parentheses. That becomes significant in this example. So just like with addition, anytime you see a subtraction symbol, whether it's between the names or between the full notation, that means you're going to subtract. So in this example A, I'm supposed to take g of x, really, and subtract f of x. Now, when we do this, we think the exact same way that we just did with the previous problem. So we look and we see that g of x is this function up here. So we know we're going to take this expression g of x and we're going to replace it with the actual algebraic terms that make up that function. So that's just 5x in this case. Now, when I go to substitute f of x this time, I'm going to write 5x squared plus 15x minus 30. But the thing I'm going to do a little bit differently is I'm going to make sure that when I write subtraction, right, because subtraction goes in between these two functions, I put it in parentheses, it being the function. Why am I putting that function in parentheses? It's because technically all of these terms need to be subtracted. So their signs are going to switch. So really, we're going to have negative 5x squared, we're going to have negative 15x, and we're going to have positive 30. And that's what we're going to take from the 5x that we had. So we're going to end up with negative 5x squared, which, by the way, I always try to write my terms in order from highest degree to least degree. So that's why I'm leading with the negative 5x squared. And then I'm going to get negative 20x because the 5x and the negative 15 are not going to turn into negative 20. That's my bad. They're going to turn into negative 10. Sorry about that. And then we're going to add 30. And this is our function that we get when we combine g of x and subtract f of x from it. Okay, so we're halfway there. Next, we have multiplication. Now, traditionally, the multiplication symbol is a times symbol. I get that, like an X, I should say. But it can also be a dot, okay? Closed dot. That's what you're going to see in function notation. Okay, I know that might be confusing, but think about if it said fxg of x. Like, think about, I'm going to erase this, but just think about if it said f of x of x. That would get very confusing because there'd be a lot of x's. Okay, so that's why in function notation, they only use the dot to represent that you're going to multiply two functions together. Okay, so what this dot here means is that you are going to take whatever f of x is, and you are going to multiply it by n of x, okay? And so I'm going to go back for a second. F of x is that long function, the 5x squared minus 15x plus, or minus 30, sorry, plus 15x minus 30, and then n of x is this other function, 2x squared minus 1. So once we've got this set up, we're going to do some distribution. It doesn't matter which way you distribute. I'm actually going to distribute backwards. So I'm going to get 10x to the fourth because the exponents add. I'm going to get 30x to the third, and I'm going to get negative 60x squared. And then I'm going to multiply everything by negative 1, which we basically just did. And I'm going to get negative 5x squared minus 15x plus 30. And if you're wondering why I kind of wrote it off a little bit, why I didn't write the terms for one right under the other, it's because I knew that this first term was going to be alike with the 60x squared, and that's actually the only term they have in common. So I wanted to line them up so that it was easy to add them, right? Because now I can just add top to bottom. So 10x to the fourth, 30x cubed minus 65x squared minus 15x plus 30. That rather long function is f of x times n of x. All right, last operation is division. Now, again, I recognize that typically this symbol, the two dots, one on top and below, this flat horizontal line, that's your normal division symbol. But I want you to remember that this slant backslash is also a division symbol. I mean, think about it. When you write a fraction, I'm just going to make up a fraction. Some people write 3/4. It's not a good idea, but a ton of people write it like this, 3/4. This is the one instance where if you write it like that, it might actually help you understand and remember that all of that is related to the idea of division, okay? And so if you see that slash in between two functions, or if you literally see two functions written as a fraction, you are going to use division. So here we're going to take our functions f of x, and we are going to divide them by g of x. Now, by the way, just a common thing I want to point out if you haven't noticed this already, the notation, the way that this is written, like f/g, it's like a condensed version of the notation, okay? it's basically saying both of these functions use the same variable. So that's why there's only one x written. Like up here, f times n of x. It means you're multiplying these functions together and both of them have x in them, okay? It's not like this set of parentheses is some separate operation. This stuff at the top is notation. Okay, this is all notation that we're talking about, okay? So this x is really both of these x's. It's like we're distributing it back to each of the functions, okay? So I know that that can sometimes be a little bit confusing for people. You just need to remember that this notation up here, you don't do any math with this notation. You don't multiply the x and the g or whatever. You just use it to represent the substituting. After you substitute, that's when the math, when the algebra happens. Okay, so I've rewritten f of x, and then I'm going to go back for a second to look at g of x, which is just 5x. Okay. And now in this case, what we're going to do is we're going to simplify this a little bit because we can. So we can take 5x squared and divide it by 5x. We can add that to 15x divided by 5x. And we can subtract 30 divided by 5x, because really that's what this fraction means. It means divide each term in the numerator by 5x. And so then what we end up getting is x to the first. We get 3x, the x's cancel. Sorry about that, we get 3. So x plus 3 minus 6 over x. And that is our new function once we've divided. Okay. So that's the run of each one of those operations, okay, and how they work and how you substitute them. So now we've got a little bit more practice. So when we have problems that we're going to practice, I am going to pause and kind of tell you to pause right now and try a couple of these, and then some answers are going to pop up. So if you don't pause, it'll look like poof, all of a sudden math happened. But really what you should do right now is take a minute, pause the video, and try these problems 1 through, I believe there's 6 problems on this page for you to try. So take a minute and try these first 2 problems. Oh, I do want to point out that sometimes the multiplication symbol is also going to look like an asterisk. Okay, so that's another thing that could happen. It could be the dot or the asterisk. Depends on the book, the context. So there are times where those two could happen. So this symbol right here in number 2 is telling you to multiply. Okay, so like I said, if you haven't already, pause this video because I've said it a bunch of times. You should do that now and then check the problems as you go. Okay, so some work will pop up in a second if you don't pause. See you back here shortly. All right, folks, hopefully you took a second to try problems 1 and 2, and you arrived at the answer of 3x squared minus 2x minus 3 for our new function n of x, and 6x cubed plus 15x squared plus 4x plus 10 for our second problem for practice. Next 2 problems both involve division, and one key thing I want to note that's different about these 2 problems from the one in our examples is that these can't be simplified, and they can't be simplified because the factor that's in the denominator, like for example, let's just look at number 4. This factor, x plus 4, you can't divide x squared minus 5 by that, okay? So because of that, you have to leave these 2 fractions in the current form they're written. That's as simplified as they can get. Gentlemen, your final 2 answers are x plus 4 over x squared minus 5. Again, doesn't simplify. Definitely no simplifying here. However, when you do number 6, after you multiply the 2 terms, the 2 functions together, you can combine the 2 middle terms to get negative 13x squared. So you should get 3x to the 4th minus 13x squared minus 10. All right, folks, that's all for function combinations today. Thank you so much for listening, and we'll come back with some more practice really soon. All right, have a good one. Bye.